So at least half of all stars are binary. We explained what happened with Algol. Well, the other thing that can happen is if you have a star that's already really high mass, so the star happens to already be really high mass, when it expands to be a red giant, it's going to be not just a red giant, but a giant-sized red giant, a red supergiant. And so your already existing really high mass star gets super big. Okay, so that means the outer edges of it can go out like 5 or 6 AU. Now, the star might be 10 times the mass of the sun, so that means it's slightly bigger than the sun as a main sequence star, but then it expands. When it expands this huge, it doesn't increase mass, it just expands. That means the outer layers are very far out and they're very thin. In fact, there's even some speculation that these supergiant stars, if you had a planet out there and you were orbiting this, if you were able to look at the star, if there was something bright on the other side of it, like a bright planet or a really bright star or something, you could maybe actually, you might actually on a planet here be able to see through the outermost edges of it because it'd be so thin. We're not really sure, but that's one speculation that's there. And so what would that do, though, if you had a really, really high mass star as part of a binary with another lower mass star, and this thing swelled up to be a supergiant? Well, normally what would happen is the star would fill its Roche lobe and dump stuff in the other star. But what if this thing was expanding so fast it just kept expanding? What would that do? Well, you can imagine it might actually swallow the other star. Okay, now, what does that mean? Well, remember, this thing is going to be super thin. So that means the other star might continue orbiting under the surface for a while. Now, how long is a while? Now, a while can actually be very long on human lifespans. Okay, so by a while, we may be talking hundreds of thousands of years, or even a million, or a few million years. So what's going on here? You could swallow the star. That would mean that this star is going to be inside the other star, heating up the interior. That would make, like a bright spot or a hot spot on part of that star right there. Okay, and then as the star orbited around, that hot spot would move around. Okay, the big star itself would also be orbiting, but rather rotating, but it'd be rotating probably at a much different speed than the thing orbiting under it. Now, it's not going to orbit under it forever. It will eventually, as it's going along, it's going to be pulling in some gas and slowing down, and it's going to be spiraling in towards the core of the other star. Now, if it spirals into the core of the other star, then now we have a bad thing happening. Okay, we'll talk about that later. Okay, if the other star dies before it reaches the core, well, that's still a bad thing. Okay, so there's no good that comes out of this. Is there any evidence that such a thing may have happened? Well, actually, it turns out if you look at Orion, the star Betelgeuse in Orion. So Betelgeuse, the star right here in Orion, if you look at it, it's a red supergiant star. So it is enormous. In fact, I mean, it is so big, the outer edges of it stick out, probably beyond where Jupiter's orbit is from one side to the other. Jupiter orbits the sun about 5.2 AU. So that means this star is more than 10 AU in diameter. And that's huge. That's enormous. That's unfathomable how big that is. The Hubble Space Telescope was able to get sort of an image here. Now, the thing is that one of the things we've noticed here by analyzing it, particularly in radio waves, is that one side of it is actually a little bit hotter than another side of it. Betelgeuse also very famously, 2020, early 2020 was getting dim. And it's an irregular variable star, so it gets bright and dim kind of randomly anyway, or semi-randomly, and it just was getting way dimmer than normal, which is actually not totally unexpected for that. And some people were thinking it's about to go supernova, but others of us were thinking, well, no, it just randomly does this sort of thing anyway, so before we get all bent out of shape, it might be just doing its random dimming. And it turns out that it actually blew out a big cloud of dust. We'll talk more about that later. But it does have a bright spot on it. Now, the interesting thing is that bright spot actually goes around at a slightly different rate than the star rotates. That's not supposed to happen. So it does suggest that this may be an example of a star that swallowed a star. Now, I will admit that interpretation of this is not accepted by all astronomers. So right now, really only about 30 to 40% of astronomers that study this take that interpretation. The other 50 to 6% say we're not really sure what's going on. But that is one possible interpretation here, and so it does lead rise to some interesting speculations here.